All right, so welcome everyone. A very warm welcome to all of you in this session for NEET 2024. So, guys, from this session, we are going to begin with. In this session, we are going to begin with the topic of units and measurement. Okay, so guys, this is a very important topic of the physics for the NEET aspirant. Okay, so this is the basics of the physics. So here, if we are good at this chapter, if we are good at this unit, okay, then definitely we are going to have a good hold on the other topics of physics as well. So guys, this topic is one of the most important topics of physics, okay, and basically it makes the basics is strong, and the concept that we are going to gain from this particular chapter is going to help you in every other chapter as well, okay, because see, we know the units are very important to describe any quantity for any subject for this matter, okay. So this first chapter of units and measurement I am going to teach you from today. And as promised, we are going to crack the NEET 2024 examination beautifully, and we are going to target maximum marks out of the physics subject. So with this note, let us start with the subject. But before that, let me introduce myself to you guys. My name is Dr. Shankar Tripathi. My name is Dr. Shankar Tripathi, and I have done PhD and MTech from Indian Institute of Technology, Roorkee. Okay, so these are some of my credentials. I have qualified the prestigious GATE examination with 99.99 percentile, and I have done it not once, not twice, but 4 times. Okay. As far as my teaching experience is concerned, I am into teaching of physics from last 11 years, and I have taught thousands of students across the nation and help them preparing for their IIT JEE and NEET examination. Okay. Moreover, I am an author of 3 international published research papers. These are internationally accepted papers. You can find them on Google or Google Scholar. And also, I have associated with many scientific journals in the capacity of editor and author. Okay, so this is the brief introduction about myself. Now, without wasting any time, let us start with this beautiful subject of physics with this chapter, units and measurements. So first of all, before let me start this topic, I want to tell you something, okay, about the physical world. Okay. Now, if I say this physical world, and if you see the books of NCERT, you will get the first chapter as the physical world. Okay. So we are not going into very much depth of it. Just a brief thing I want to tell you here. So what do we mean by physical world? If I say so, see, anything that is around us, anything that is around us, anything that we are seeing happening, physics is involved in one way or other. Okay, right now you are watching me. Okay, so when you are watching me, there is physics involved in that because you are using your energy to watch me, to absorb the content, to absorb the things, the concepts. So for all of it, you see, physics is involved. Okay, not even a single thing in this world happens without the physics, right? Like for example, we are doing exercise or we are going outside, we are walking, and these days we say that we are trying to burn our calories. When you go outside in the morning or in the evening, I hope you must also be doing this, and you may see many people walking around, running around, they are going for the gym. So physics is involved in that also. Okay, so like for example, I'll give you a simple example. Let us say that we have a person, okay, and let his name be Balram. Okay, so we have a person Balram. So every day in the morning he start to eat something. Okay, so some things he eats. Okay, so basically when he's eating something, he's taking the energy, okay, out of what he's eating. Okay, okay. Now when Balram goes to exercise, when Balram goes to exercise, or maybe let's say walking, okay, let's say he goes walking or he goes running, or he goes to some fitness center or gym, or he may go to play badminton, tennis, cricket, or anything. So what happens? So whatever energy you have gained, okay, from the food, you are expending that in some way. Okay. Okay. So if you don't expand the energy from what you eat, what is going to happen? You are going to gain the weight. Okay. Like if you see me personally, I am a person of very heavy weight. So what it means that I am not very good or not very fond of exercising. I don't go walking, running a lot. Okay. Okay, so that is why what happened, the calorie has been gained in my body. It is just nothing but the first law of thermodynamics. Okay, that is what we are going to see in the physics later. Okay, okay, so like this is a common phenomenon. Everyone knows it. You rather not be a science student, even the arts student, even the student of commerce, even the student of anything in this world on this date knows that when they eat more and they expend less, they are going to gain the weight. They are going to gain the weight. Okay, okay, this is happening. Okay, so now why they are gaining the weight? Because if you are you are taking some input and you are providing some output. This is some form of the input in a way, and this is some form of a output. This is the form in the output. So when the output is less than input, the energy is getting stored inside of you. So this is nothing but the first law of thermodynamics that we are going to see very extensively when the time comes. Okay, just give you one example. Okay, we can have many more examples like that. Anything, as I said, like you do. So, like for example, I am speaking. For that, I require some energy. From where this energy comes from? This energy comes from whatever food I have taken. Okay, okay. So similarly, everything possesses some form of energy, or I can say some form of physics is involved in every action around you. Okay, okay. You are charging your laptop, you are charging your mobile from which you are watching me right now. Some form of energy is involved there. Some form of physics is involved there. Electricity. You are living in some room. You can see that the fan is, you know, rotating around you. You might be sitting in air conditioner. Some form of physics involved there. Everything, as I said, everything is the physics. Okay, okay. So what do we mean by the physical world? So from physical world, I can say that that everything, everything around us, everything around us, which involves, okay, which involves some concepts of physics, some concepts of physics is nothing but your physical world. Okay. Now, as I said, there is nothing in which the concept of physics is not involved. Even the blood is flowing in our body, everything. You name everything, I'll tell you what concept of physics is involved here. Okay. So the live student, if any doubt, you are free to ask me. Okay, I'll be more than happy to answer your queries on the live chat on YouTube. Okay, so as I said, physical world is what is around us. Okay, now from where this physics begins. Okay, so there is some people that you call scientists. Okay, so back in the date when all the laws that we studied today, there were no scientists. Okay, so sir, who developed this law? So these scientists were named as mathematicians. Okay, all the person rather they are doing something into chemistry even, they were called as the mathematicians. So that was the name was prominently used in those times. Okay, now if I say that what is the role of the scientist in our world? Okay, what do scientists do? So these scientists, say Newton, say Einstein, say Archimedes, say Hooke, say Poisson, okay, say Rankine, any scientist, what is the purpose and what role they played for us or to the world? So scientists basically, what in my opinion, okay, in my opinion, and in the opinion of many others, obviously, so they are observers. Okay, they are observers. Okay, So see, my way of teaching is in a way like you have to think of the thing. Okay, you'll have to interact to me. You'll have to think that what is sir is saying and what is the logic behind it. Okay, okay. See, competitions in the studies of competition, you have to think a little out of box. Okay, you can't just follow the labels merely, and you can't do memorization of each and everything. So you have to understand the things first. Okay, so for that, I'm telling you this. So scientists are basically observers. Okay. Okay. What observers are they? So for example, there was a person named Newton. So what does Newton do? So one fine day, what happened? Newton went and he saw an apple falling. Let it be your apple. So from a tree, he saw that this apple falls and reaches the ground. Okay, from the tree, this apple fell and it reached the ground. Okay, it reached the hello cakewalk. Okay, so this reached the ground. Okay, now what he did, he observed this phenomena. Okay, apple is falling down. Okay, now he observes and he came up with the concept of gravitation. He came up with the concept of gravitation. Okay, okay, and then he formulated this Newton's law of motion and so many things. That is a different story. But for when he saw this apple is falling, he came up with a law of gravitation, that this apple, when it always fell to the ground, okay, it is always falling to the ground. That means there must be some phenomena that is given by this nature. Okay, this phenomena. So see, before the Newton have saw the apple falling, was it doing anything otherwise? Like before Newton saw it, apple was going up towards the sky. Was that the case? No, sir, it wasn't the case. Apple was always falling. Okay, what Newton did? Newton came up with this law. So what he tried to do, he tried to understand this phenomena and made a law out of it. Okay, so basically my point is that laws are developed from the nature. Okay, laws are developed from existing ways of nature, from existing ways of nature. Okay, so this is a very big statement. Let's try to understand it. Okay, so as I said, before even Newton came up with the law of gravitation, this apple always fell. So gravitation was there beforehand. It wasn't like that gravitation was not there. Okay, gravitation was there. Gravitation was already there. But what role Newton did play? Okay, what role did the Newton played in it? So Newton observed it and made a law from it and presented it to the world. Okay. So what is the use of this law when it is already existed? So see, when we give up a law, when we provide a law, when the scientists provide a law, so the very purpose is to at times manipulate the nature. Okay. Right now, recently we reached to the moon. Okay. So there the gravitation is different from that of the earth. Now, how come we reach the moon? Now, for that, we must understand the gravitation. Okay. And from these laws, these are the basics to see. Today, we reach the moon. Okay. But if Newton wouldn't have provided us with the law of gravitation, would it be possible for us today to reach the moon? Okay. No, sir, it wasn't possible. Okay. So, at times, these laws are manipulated. At times these laws are improved. Okay, like for example, you must have heard of speed of sound. If you haven't, don't worry. Okay, we'll take everything when the time has come. You just follow my lead. Just trust me. Okay. So guys, Newtons have firstly given the speed of sound, but later Laplace corrected it. So these laws are always subjected to some sort of improvement. Now, to summarize this, so scientists are the observers who observes the ways of nature and then formulates some form of a law to it so that the rest of the public or the rest of the world will easily be able to understand this. Okay, like no matter what teacher, like I came up, I did all the doctorate, I published all the research papers, so that is fine. But what right now I am doing, right now I am just an interpreter. Okay, so these fine person have made a law of something, and now I am explaining this law to you guys. Okay, okay. So these scientists are the observers. They see that how this nature works, and they present this nature, this working of this nature in the forms of laws. Okay. Now, as a scientist, now please bring yourself into a shoes of the scientist. Now, let's say you are a scientist and you have to explain a lot to me. Now, how you are going to do that? Now, for that, you must be needing a language, don't you? What do you think? Okay, so the scientists required some sort of a language. So, for example, right now I am speaking to you in the language of English. Okay, now any person who is good in Spanish, will he be able to understand me? If any person doesn't know how to communicate in English, he won't be able to understand. So, before you want to convey your thoughts, before you want to convey the laws, as a scientist I have made, I have, let me, in all the humility, okay, I would say, let me, just think of me as Newton. Now, if I am Newton at that point of time, I want to explain what I have learned to the rest of the world. I need a language to do that. Don't I? Now, if I say the gravitation, so unless gravitation is a word which is understood by the rest of the world, they won't be understanding the meaning of it. Okay. Now, now this world, the scientists were required a language so that they communicate to the world in the same way as we are communicating right now. Okay. Now, this language that is required by the scientists, for those, they have, given a word, that is the physical quantities. Okay, so physical quantities are nothing but the language given to us by these scientists. Okay, okay, okay. So physical quantities is something which helps us to describe any law of physics. Okay, so it helps us, basically, it helps us, it helps us, okay, it helps us describe any law to us, or any phenomena to us. Okay, any phenomena to us. So, for example, and by knowing or unknowingly, we are using these physical quantities, this language in our day-to-day work. Okay, okay. Like, for example, if I say temperature, okay, sir, AC is on, I am feeling cold. Okay, sir, temperature, please reduce the temperature of the air conditioner. This is the common things we use in this world, no? So temperature is what? Temperature is sort of a physical quantity. Now, when you say temperature, this temperature word is known to everyone else. Now, when you say that please reduce the temperature of the air conditioner, each and every person around you knows that what you intend to. Okay. So this temperature is sort of a physical quantity. Okay. Every other day we say, okay, it is so much of tough examination. Okay, I'm feeling so much of pressure, right? Pressure is a physical quantity. Now, when I say that the pressure is there, I am feeling some sort of a pressure. Okay, so everyone around me knows that what I mean by the pressure. Okay, 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 right. Right. So this physical quantity helps us describe any law or any phenomena to us. Okay. And this whole physics is based upon this physical quantities. Okay. In each and every chapter, we'll come up with some new physical quantities and like to try to interpret that. Okay. And in this very chapter of units and measurement, we are going to see most of this physical quantities. I'll try to come up with almost each of this physical quantity so that you have some idea and so that you can use it in the future chapters as well. Okay. But to the flow of this subject, like when we go to kinematics, we'll talk about displacement, we'll talk about speed, velocity. All these are physical quantities only. Like the language, as I said, okay, to make people understand, okay, this is happening in this nature due to this phenomenon. Okay, so how can we define? See, definitions are very important and very soon. See, physics for NEET is, I would say, you will have to have 98 to 99% it is numerical based. Okay, so just I'm giving you some understanding of this physics because see, I believe when you understand some topic, okay, when you learn the concept, okay, so if you have to run in a long race like the NEET or for any competitive examination that is a must, you must understand your foundation must be strong. Okay, so it is that 98-99% numerical subject, and we are very quickly moving towards that. Like within I think 10 minutes, after 10 minutes, you will see numericals running in. And as I said, all the NEET questions, previous year question, most of them we are going to do in the classes only. Okay, okay. So let me proceed. So this physical quantities, how can we define them? How can we define them? So definition of physical quantity. Okay, definition of physical quantity. So this physical quantity, I'll be from next onwards, I'll be telling it as PQ. Okay, so basically this is the quantity. How can we define it? So we can define it in very simply. So the quantities, the quantities the quantities which can be measured, okay, which can be measured by, which can be measured by an instrument, which can be measured by an instrument, and which describes, which describes the law of physical world, which describes the law of physical world. Okay, so the quantities which can be measured by an instrument, like for example, so many things are there: length, okay, area, volume, mass. So these are all measurable, and there are so many of it. Okay, okay, so the quantities which can be measured by an instrument and which describes the law of physical world is known as the physical quantity. So basically where we are going to use them. So we are going to use them. Okay, so these are going to be used. So it helps us formulating equations. Okay, so we are going to see many equations in this beautiful subject of physics. So every equation will consist of some physical quantity. Okay, okay, so it helps us formulating equations. Okay, again to understand the laws of physical world in a better way. Okay, laws of physical world in a better way. Okay, okay, okay. So guys, now we have understood that what is a broad meaning of the physical world. Okay, so every phenomena that is happening around us is due to some law. Okay, so have we if I ask you, like, have we understood all the ways of nature? No, we haven't. And trust me, we will never be able to. Okay, with all the my experience in this scientific community, I can tell you that it is impossible to know everything about the nature. Okay, no matter how hard we try. Okay, but as a human being, we always try to approach to understand the nature in more better way. Okay, so whatever is happening around us, we try to that why it is happening like this way. Okay, why it is happening this way, and for that we need the law of nature. Okay, so scientists gave this law, and they needed a language for them and for others to understand these laws of nature, and from where this physical quantity came, word came. Okay, so it is the language in which the physics is explained. Okay, so this physical quantities must be measured, because when you are explaining some law, or when you are explaining something in terms of this physical quantities, first of all they must be measured. Okay, okay. Then in the whole journey of physics, what we'll be doing, we will be forming the equations, we'll be forming the formulas, we will be forming relations between this physical quantity, and later on we'll see that if one physical quantity changes, how it affects one or more of other of the physical quantity. So this is basically how this world of physics goes. Okay, this is basically how the world of physics proceed, how the world of physics goes, right? Okay, okay. Now the question is, sir, how we are going to interpret this physical quantity. So let us take a very basic example. So length. Okay, from the very beginning of our schooling, we have a meter scale with us. No, we carry this meter scale in a beautiful geometry box to the school, to the nursery, to the play school or whatever. Okay, so this meter scale is used to measure the length. Okay, so now how you are going to interpret this length? So you say like this: the 10 centimeter. This is the standard way, or you may say 10 meter. Okay, okay. So like this, when we have length is equal to 10 meters, so length is a physical quantity. Okay, it is a physical quantity. Now to describe this physical quantity, you required a numerical value. Okay, this is the numerical value obviously, and this is the unit. So simply any physical quantity is consist of two things. One is the numerical value and the other is the unit. Okay, okay, and in this chapter we are going to focus upon unit. Now if I ask you that why we needed these units in the first place, what is the need of this unit? Do we need this unit anyway? What is the need of this unit? Can you think of it? Why do we need this unit? Now, just think of a way. Like for example, oh, I'm sorry for this. So let me give you an example. So my weight, if I want to convey that what is my weight to you, now how I am going to convey you that? How I am going to convey you that? So I am going to convey you that, like I would say that my weight is, let's suppose it is 120 kg actually, really. I'm a fat guy because I don't apply first law of thermodynamics quite seriously. Okay. So 120 kg is my weight. Now, if I want to convey this, so when I say 120 kg, you have a mere idea, okay, that sir would have been very fat or something like that, right? Now, if I interpret my weight like this, that my weight is equal to 10 times of weight of Rahul. Okay, Rahul. Now, if I this way I interpret my weight, would anybody be able to understand or get an idea that what my weight is? You tell me. No, sir. Because Rahul is no standard. There are so many Rahul. Some Rahul may be fatter than me, some Rahul may be thinner than me. Okay, so this is no way, no. Okay, this way, if we start expressing any physical quantity, if this way we start expressing any physical quantity, will it work for us? No, it is not going to work for us. So from there, this thing of unit came up. Okay, so from there, this unit thing came up. Okay, because we want to convey in a way that a person sitting in India is also knowing that what I mean by 10 meter or 120 kg. A person sitting in Japan also must know that what I mean. Okay, what I mean. Also, also, the person sitting in America must know that what I mean. So to have a standard to this physical quantities, we came up with this term of unit. Okay, to provide a standard to whole of the world. Okay, so let it be anything like Temperature. Temperature is also a physical quantity. Now, when I say that temperature is normally we represent it in degree Celsius. Okay, so this degree Celsius is not SI unit. I'll come to that. Okay, but still it has unit and internationally accepted unit. So when we say 40 degrees Celsius, okay, people come to know that okay, this is what it means 40 degrees Celsius, right? What is the temperature? They get a sense, right? Like if I say today that okay, come to my place, come to Roorkee. I live in Roorkee, in IIT Roorkee. Okay, so come to my place. Okay, the temperature here is 40 degrees. Let's suppose. So you before coming to me have the idea that how hot it is going to be in Roorkee, right? Right. Like for example, in summers we go to some hill stations, right? For holiday purpose. Why we go there? Because we know that temperature there is less. So we have already some sense about the temperature, that what it describes, what its interpretation is. Okay. Okay. So all this thing we already know. So again, see temperature 40 is the numerical value. 40 is the numerical value, and degree Celsius is the unit. Okay, so what is the point? Every physical quantity is described with the help of the numerical value and the unit. Okay, now what are the different types of this physical quantity? So in the world of physics, these physical quantities are described in the following three ways. Okay, so in overall physics, these physical quantities are broadly classified into three. One is fundamental, one is fundamental quantities. Okay, okay, quantity. Okay, after the lecture, guys, these notes I'll provide you. Okay, whatever I'm writing, I'll take this notes, make the PDF, will upload here, so you can have it downloaded, and you can also subscribe the channel. Okay, you can also subscribe the channel for more videos. So from today onwards, we'll be coming up uh, as early as we can with more of these sessions. And this is the first session of physics for NEET today. So I am starting with this units and measurement. Later, I'll cover the whole physics for the NEET in a period of 4 to 5 months. Okay. So fundamental quantities we have derived quantities. Okay, and then we have supplementary quantities. Okay, so supplementary quantity. Supplementary quantity. Okay. So physical quantities can be further classified into three: the fundamental quantities, the derived quantities, and supplementary quantities. Now, what do we mean by so fundamental quantities? First, let's talk about fundamental quantities. So, what do we mean by fundamental? In general, what is the meaning of fundamental? So, the meaning of fundamental is the basic. Okay. So, fundamental quantities are the basic quantities. Okay. Okay. So, everything is made of some basic things. No? Like, for example, if you want to build your home, you require bricks. Okay. So, home is built from the bricks. Now, similarly, this whole physical world or the physical quantities are built up of fundamental quantities. Okay. So, how can I define these fundamental quantities? So, these are the quantities. These are the quantities. These are the quantities which are used to derive any other physical quantity. Any other physical quantity. Okay. Okay. So basically, fundamental quantities are those using which you can derive any physical quantity in this world of physics. Okay. Okay. Or I can say in one more way. So these are simply independent. So these quantities are independent of any other physical quantity. Any other physical quantity. So the quantities which are independent of any other physical quantity is known as the fundamental quantities, or simply the fundamental quantities are those using which you can develop any other quantity. Okay. So in the world of physics, these quantities are seven. Okay. So we have seven physical quantities. How many? So there are seven physical quantities, seven physical quantities which are fundamental quantities. So we have seven fundamental quantities which are further used to describe the whole physical world with the help of other physical units. Like for example, we are using, as I said, we are using the English language. So what are the fundamentals of English language? So fundamental of English language is that we have 26 alphabets. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Isn't it? So we have 26 alphabets. So using this 26 alphabets, what we have done? We have developed this whole English language. And now I am communicating with you in English language. Okay, but all the words, everything of this English language is made up of this 26 alphabets. Now, in the same way, these seven fundamental quantities are used to describe any other physical phenomena, any other physical quantities. So, what are these fundamental quantities? The live student can respond to it. What are these fundamental quantities? So, while you think, I'll make a table here. Okay, so let's say we have here fundamental physical quantities. Okay, fundamental physical quantity. Okay, now we are going to use SI units. Okay, so in India we generally follow the SI unit. What is the full form of SI? So in French, it is basically the same internationally of the units, right? Because it was first given by French people, okay, and it is accepted in 1960 in the General Conference, 11 General Conference of Weights and Measurements. Okay, so from then onwards, SI units are popular, okay, in India and in many abroad nations. Some nations are exceptions. Like if you go to America, they generally follow the pound feet system. Even today, that system is popular in the general mass. Even in Indians, if you ever go to like see any land or if you purchase land, you talk in mostly square feet, isn't it? Ask your father whether he purchased some, the property or something. He must be knowing. So normally in India we do with a square feet. So the units are just there for the interpretation, and it is the matter of location, people choices, that what unit they are preferring. Like British use Fahrenheit. Like even today, when we measure our temperature of the body, the temperature is given in Fahrenheit. So Fahrenheit is again one unit of this temperature, but neither degree Celsius nor Fahrenheit is SI unit. Okay, so in 1960, in 11 General Conference, the world came up with this SI unit thing just for the purpose that whole world follows the same standard of unit for ease of interpretation, measurement, and trade. Okay, because obviously when you are converting one unit to another, there may be some chance of error. So in this world, we are exporting something to other nations. They are exporting something to us. So if there is any difference in the measurement, it will be a huge issue. Okay. So this was the purpose of SI unit. Okay. This is just the additional information. And third thing we would be requiring is the symbol of these units. Okay. Now, what are these fundamental units? Any student in the live who want to communicate me, who want to tell me that what are these fundamental units? Anyone? I can see that we have some live students here. Anyone who would like to tell me that what is the fundamental unit? All right, so I'll come up with it. So the very basic fundamental unit is the length. Okay, and the SI unit to length is meter, and the symbol to this length is m. Okay, then we have the mass. Okay, so you can number it any way. Okay, that is why I'm not writing 1, 2, 3, 4, because the mass can come first, length can come first. That doesn't. There is no rule regarding that. So it is the SI unit of the mass is the kilogram, and it is symbolized by kg. So I am writing all the SI units. Then we have the time, right? We have the time. Now this time when I say, so what is the SI unit? The SI unit is second, and it is going to be represented as S. Then we have this temperature, okay? Then we have this temperature, and the SI unit of the temperature is Kelvin, and this is described as in the symbol of K. Then we have this electric current, and this electric current SI unit is ampere, right? Okay, many of you must be knowing all this, huh? Okay, then we have intensity of light. Okay, what is the unit of intensity of light, anyone? And what does it represent? Okay, so again we will be talking about it when the time will come, okay, in the more extensive manner. But for time being, if I ask you what is the SI unit to it, so the SI unit of this is candela, right? Okay, and what does this represent? So, sir, this represents the energy of light. Okay, the intensity of light is represents the energy of light. So we have intensity of light, the unit is candela, okay, and this symbol is CD. Then we have one last, that is amount of substance, okay, amount of substance. Okay, so when we are going to read this thermal part, we'll be talking about it. Okay, so amount of substance, what is the SI unit? Mole, and it is given as MOL. What is the symbol? Symbol is MOL. So these are your 7 fundamental units: 1, 2, 3, 4, 5, 6, and 7. Okay, so these 7 fundamental units are used to describe any physical quantity that you are going to see in future or might have seen before you came to this lecture. Because the way I'm teaching, I'm thinking that all of you are novice, like you don't know anything in the physics. So this is the way I'm going to teach you, and later on we'll speed it up. Okay. Now from this fundamental unit, okay. Now from this fundamental units or fundamental quantities, we can come up with any derived physical quantity. So how can we define this derived physical quantity? So this derived physical quantities can be derived. These derived physical quantities can be described in terms of. So these are from made from. These are made from or from the fundamental quantities. So these are made from what? These are made from the fundamental quantity. Okay. So any quantity that can be described in terms of the fundamental quantities, any quantity which can be described, which can be described, which can be described in terms of fundamental quantities is known as the derived physical quantity. Okay. Okay, so like anything, it can be anything. So if I ask you how many, like we have given the number to the fundamental quantities, how many? If I ask you how many are the derived physical quantities, so how many? Okay, what would you say? How many derived physical quantities? So I may say that these are infinite only. No, there is no count to it. There is no count to it. Okay, there are so many physical quantities, so many. Okay, you can't just count them. Heat, charge, potential. Okay, potential difference, capacitance, inductance, right? Velocity, acceleration. right? Anything, force, pressure, stress, right? Young's modulus, some coefficient of gravitation. Okay, okay. So there are so many derived quantities that you can't just count them. Okay, with each and every chapter will come up with some new physical quantities, and if these physical quantities are other than what we have written previously, the fundamental quantities, then this is a derived physical quantity. So, as the name suggests, the derived physical quantities are those which are derived from, or which are made up of, or which is made from the fundamental quantities. So, for example, area. Very simple, area. So, what is area? Area is length into width. Okay. So, what is this unit? So, meter for length, and we'll be using the SI unit throughout the journey of this physics. So, length into width, that is meter square. Now, here, if you observe, here if you observe this, so here if you observe this, so if you observe it, if you observe this, so here I can see that the fundamental quantity is used twice. No, is used twice, right? Okay, okay. So the fundamental quantity or the fundamental unit, that is the meter, is used twice. Okay, here you can say this length and width, both are the fundamental quantities, because width is also some sort of a length. No, okay, okay. So this width can also be written as length, right? That wouldn't be a problem. Okay, okay. So this fundamental quantity is used twice. Volume. Okay, okay, so you can say this L into B into H, but B and H is also the form of length only. Na? Okay, in the world of this physics, they are also measured by the same instrument. So L into L I can write. So here you can see that the fundamental quantity is written thrice, and what is going to be the unit of it? The unit is going to be meter. The unit is going to be meter. Now, similarly, if I say we have this velocity. Okay, so there are, in as I said, there are so many. We can't just write them. So I'll just give you what I want to, and then later on we'll do everything. Don't worry. Okay, just follow my lead. So if I say this velocity, if I say guys this velocity, so this velocity is displacement, rate of change of displacement per unit time. So we can write for time being displacement per unit time. Although it is not exactly displacement per unit time, it is basically change in displacement upon change in time. That is something different. We'll come to everything, don't worry. Just right now we are focusing on units and measurement. So displacement per unit time. So here displacement is some sort of a length and time is some sort of a second. Okay. So here again you can see that the fundamental quantity is used more than once. Okay, meter per second. That is, it is a combination of two fundamental quantities. Okay, okay. If I say force, so what does the Newton Baba said? He said that force is equal to mass into acceleration, the rate of change of momentum from the Newton's second law. Okay, again we are going to see that. Don't worry. So F is equal to ma. Now, if I derive the unit of it, what is this mass? So mass is, for mass we have kg. This is a fundamental quantity. Now, acceleration itself is not a fundamental quantity. So, acceleration is basically change in velocity upon change in time. But for time being, let me write velocity per unit time. So, what is the unit of this velocity? It is going to be meter per second. What is this time? This is second. So, basically, this is going to be kg meter per second square. So, here you can see that we have more than two fundamental quantities. Okay. So, simply, what is the derived physical quantity? So our derived physical quantity, which uses the fundamental quantity, which uses a single fundamental quantity more than once, like volume, like area, or which utilizes combination of fundamental quantities to express itself. Okay, like for example, this force kg meter per second square, which is nothing but Newton. So Newton is what kind of a unit? Is it fundamental quantity? Is it a derived quantity? Okay, so this Newton is nothing but this thing only. See, Newton is nothing but this is Newton. Okay, this kg meter per second square is the unit of Newton. Okay, so Newton is what? Newton is not a fundamental quantity. It is what? It is a derived unit. Okay, because it is derived out of the fundamental quantities. So derived units or derived quantities are those which utilizes fundamental quantities more than one, or it uses the combination of fundamental quantity to express any physical phenomena or any physical quantity. Like the same, so I can give you infinitely many examples here. So work is equal to force into distance. Okay, now many would say that this is d sine theta. Okay, just forget about it. I'm just focusing upon the unit. So force into distance. So force is not a fundamental quantity, but I can write it like Newton. Okay, because we just have seen that kg meter per second square is the Newton. Okay, and or I may write it as kg meter per second square. Your choice. Okay, then distance, that is meter. So obviously this is going to become kg meter square per second square. Okay, so obviously this is again a derived unit, and work is a derived quantity. Okay, so quantity is expressed with the help of unit. So the units which are there to describe the fundamental quantities are fundamental units, and the derived units are those which helps or which are there to express the derived physical quantity. Okay, so this is derived physical quantity, and later it is named after a famous, I may say very famous scientist, the Jew. Okay, okay, Joule. Okay, so again the Joule, if I ask you, the Joule is what kind of a quantity? It is again a derived. The Joule is what kind of a unit? It is a derived unit. So I hope you understood the meaning of fundamental quantity, derived quantity. Now we have one more. We have something known as the supplementary quantity. Now guys, be very careful here, because many students confuse here, and even like in many examples, in many questions, this is asked also. So this is a very important concept. Now please pay attention here. So what is meaning by supplementary quantity? Okay, so supplementary in general, what is the meaning of supplementary? So there is a lot in the name also. So what is the supplementary quantity? So for that, what is the meaning of this word supplementary? So supplementary in general, guys, means something which is extra, isn't it? Something which is extra, right? So something which is extra. So basically, we have developed some fundamental quantities. We have developed some derived quantities. Now there are one more quantity, that is the supplementary quantity. So this is neither fall in the fundamental quantity, nor it falls in the you know physical quantity. Okay, sorry, derived quantity. So this is neither the fundamental, this is not derived. So there are two supplementary quantity we have. One is angle, okay, or it is also known as the plane angle. Okay, so in general, the angle what we are using is also the plane angle. Don't get confused. And then we have the solid angle. Okay, so there are two types of physical quantities. One is angle or plane angle, and other is the solid angle. So what is this angle? Okay, if I say what is this angle, so all of you must be knowing, no? From the very initial of our schooling, we come up with this angle, na? So between two lines what we draw, let's suppose this is theta. So this is what is known as your angle. This is what is known as your angle, right? And now if we want to define it, how we can define it? So you may say this is an arc and this is the radius r. So you must have read this in 10th also, no? That angle is what? So angle is arc upon r. Okay, arc upon r. Right. If you go for NCRT, it would be written like d theta is equal to ds upon r. Right. So basically, this arc, when this arc is reduced to very small length, it is written like this. So actually, this is the correct interpretation. Okay, but for time being, we can use this also. That doesn't do nothing to worry about in that. See, whenever we use d theta ds, so it is basically telling you that the thing is reduced to infinitely small. Okay, so in our journey, I'll give you the concept of differentiation, the concept of integration very, very quickly. Just that much is required for your NEET preparation. Okay. See, there is a difference. So when you read physics in a general way, like JE students is also studying with you, JEE. So in the mains and advanced, the mathematics level, the amount of mathematics they have to put into the physics is different, and what you require is different. Okay, if you are aspiring for the NEET examination only. Okay, so I am going to tell you in this physics lectures only that what amount of differentiation, or till what level you must know the differentiation and integrations to help you in the concepts of the physics. Okay, so this is angle. So what is the unit of angle? What is the unit of angle? So the unit is, and what we are talking about the SI unit. So the SI unit of the angle is radian. Okay, and how we describe it? What is the symbol of it? The symbol is RAD. Right. Okay, so this is how we can describe the angle. Okay, so this is a complementary. This is what? This is a supplementary unit. Okay, this is a supplementary unit. So what is so special about supplementary unit? I'll just tell you. Let me tell you the solid angle first. So what is the solid angle? What is this solid angle? Okay, so this solid angle, so basically, if you are seeing the angle, so the normal angle or the plane angle is between two lines, right? Now, when you are seeing, or when you try to see this angle, in three dimension, when you try to see this angle in three dimensional in the 3D frame, then the angle is known as the solid angle. Okay, like for example, we have a cone, something like this. Okay, we have a cone, something like this. Okay, now this is a 3D geometry. No, so now if you see that these three-dimensional edges, so they are extending some angle towards any point. Okay, like this. Okay, like this. So this is what? This is a sort of this is the sort of the solid angle. Okay, okay. Arizal, we didn't understand this. No problem, no problem. Just think of this way. So you might be sitting in a room, right? And you can see the ceiling ahead of you. Now, there are four corners to this ceiling. No, now you are sitting at a point. Now, extend one line from all these corners towards you. Okay, got my point? We have a ceiling. Okay, we have a roof over us. Now, to that roof, what you do from each of the corner points, you extend a line towards it. Okay, so basically solid angle is that when so a solid body in three dimension, when all the edges are subtending their angles to one point, and that is how it look like. So that is known as the supplementary solid angle. Okay, okay, I hope now it is fine. Okay, like if you go for NCRT, you would see the figure somewhat like this, right? Somewhat. So pardon my drawing skills, no? So basically, this is your solid angle, no? This is your all the lines when you join all these corners. So again in NCRT, it is d sigma, it is dA. So what is this solid angle? This is dA upon r square. It is dA upon r square. Okay, so from here, what you can say, this area A, or if this is R, so from here you can write, so this is your solid angle, okay, and this is A upon R square. Okay, okay, so when we use this B, psi or D, so when we use D behind any of the quantity, it means that we are assuming it to be very, very small. Okay, so what is the unit of this solid angle, and what is the symbol of it? So we are interested in two things. What is the SI unit and what is the symbol? So the SI unit of this solid angle, is steradian. Okay, and the symbol is okay. So steradian. Okay, this is how we represent it. Okay, So the sorry. So this is the solid angle and the unit is steradian. Okay. 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 Now let's move to now let's move to uh, let's move to the meaning of these dimensions, because see, when you understand, okay, when you understand, so I was saying the symbol, I- okay, SR, okay, the symbol is SR, okay, wonderful. Now, 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 so let me come to, okay, let me do one thing. Let me tell you what is so special about supplementary quantities first, and then I'll describe you the dimension. Okay, because the what is special about this supplementary quantities is this. So remember one thing. Remember one thing very very special about it. So supplementary quantities are supplementary quantities are the only quantities are the only quantities are the only quantities which have unit. Okay, they have unit like radian, steradian. Okay, but they are the only quantities which has unit but no dimension. Okay, they have unit but they do not have any dimension. Okay, okay. Okay, so supplementary quantities are the only quantities which has unit, but they do not have any dimension. Now the question is, sir, what is this dimension? What is this dimension? Okay, so the dimension thing we are going to take up in the next session. But let me give you one definition. I'll say the definition today. We'll explain it to in the next section. Okay, so dimensions are the powers to which the fundamental units are raised to describe any physical quantity. Okay, okay. I'm not going to write it today. I'm going to explain the dimensions to you in the full context in the next session. Okay, but one special thing, supplementary quantities are the only quantities which has unit but no dimension. Okay, okay. So see, every unit other than these two units have dimensions. Okay, okay, okay. So why it is so special? What is exception to it? Okay, so for example, we have said like we have the unit of length. Length is meter square. Okay, so it has some dimension. We sorry area not length. Area is meter square. Volume unit is meter cube. Okay, so this quantity has unit. It has some dimension. Force kg meter per second square. Okay, so it has the unit. So any quantity which has unit must have dimension other than the supplementary quantity. Remember that work. Work is what? Kg meter square per second square. So in this whole world of physics, again I am saying any quantity which has some unit must have dimension. Must have dimension except the supplementary quantities, that is angle and angle and the solid angle. So supplementary quantities are those quantities which have unit but it doesn't have dimension. And as I said, dimension is what? It is it is the power to which the fundamental quantities are raised. It is the power to which fundamental quantities are raised to express any derived quantities. And with this definition, I'll be ending today's session. And in the next session, I'll take you to the world of dimensions. Okay. So in the next session, we will be talking about the dimensions. Okay, in full depth, everything that you need for the NEET examination. We are going to see the questions, and in the same way, we'll proceed in this particular subject of physics for particularly NEET examination. Okay, so guys, thank you very much. I hope you enjoyed watching this session. I hope you find this session helpful to your studies. Okay, and I hope to see you in the next upcoming sessions as well. Okay, so for the notes of this particular session, whatever I have written here, okay, you will get in the description, okay, very soon. And I request you guys to subscribe the channel NEET Success Simplified for more such videos. So biology is also running. Okay, Harsh sir and Khadija ma'am is taking the biology for you. Okay, I am taking the physics for you. So we together are going to take you towards your ultimate objective of the NEET 2024 examination. But for that, you have to come and join the session. You have to watch these YouTube sessions. Okay, and from the next sessions onwards, I'll be giving you DPPs also, daily practice problems, and we can have them discussed in the special classes or in the community. Okay, okay. So, guys, with this note, let me end this session. So, guys, thank you very much. Have a good day, and we'll see you in the next session. And please don't forget to subscribe and like the video.